Okay. Okay, today, strings and arrays. These are all both concepts that you've already encountered in your first language. Java does them just a little bit differently. Conceptually, you've encountered it. When we start manipulating strings, the first way is through concatenation. Take a couple of strings and kind of stick them together. The fact that Java strings are immutable has some sort of little gotchas about that. And Java decided to overload the plus operator, so it uses plus for concatenation, very fairly standard. But then what happens when you take a string and a number and you concatenate them? So what goes on? There are a few little gotchas there we'll take a look at. We'll take a peek at arrays, and then for some reason the book doesn't talk about this important, what I feel is an important class called the scanner, and that's something that you'll be using for your next assignment, so I wanted to show that to you. Okay, so strings. Strings. Okay, so I understand that strings are immutable, and that leads to a little bit of confusion, because we can manipulate strings and produce another string, but at least, and maybe I'm projecting my own my own confusion on this, but a lot of times it would be I'll manipulate a string and I'll think I've changed the string and forget the fact that the string hasn't changed, and so there are consequences to that. You should be able to declare a string variable and assign a string constant to it, concatenate them, and then as far as arrays go, to be able to declare an array and instantiate it, understand that arrays are objects, to be able to assign the values to an elements of an array. And here is where there's a stark contrast between the way Java does it and the way Python does it, and other approaches. Java is much more restrictive. And then I'll show you how to use scanner. It's very easy. But okay, strings. They're not primitive. So yesterday we talked about primitive values, specifically numbers, booleans, characters. Those are primitive. Strings are objects, and starting next week, we'll delve a little bit more deeply into what that really means, and how there are consequences for things like what happens when we pass an argument to a method, what goes on with that, kind of understanding references to objects versus primitive things are important to understand that there are consequences of that. So, okay, string constants. You should be familiar. Double quotes. So here's a string constant. Right here, we define them by double quotes. That's strings and arrays are, even though they're objects, they are unique in how we can instantiate them. All other objects, we have to use something called a constructor. Now, when you learned Python, did they talk about objects at all? And a little bit. Let's see. What's the other? Have you talked about JavaScript in any of your classes? Okay, so in JavaScript they probably talk about objects, and okay, now that's unfortunately that's going to cause some confusion, because JavaScript, the way they do objects is, well, my mama told me if you can't say anything nice, don't say anything. So I'm not going to say anything about how JavaScript does objects. But there will be some confusion because Java does things very differently than JavaScript, and even though they both have Java in them, they are totally different things. Anyway, okay, strings are immutable. They can't, once you create a string that is this, you can't change it. It's absolutely fixed. but you can reassign the string variable. So, for example, here I've this particular object, string object, cannot be changed, but I can say, name is equal to, if I do this, if I say name is equal to, something else here, then that will change the, whatever I put in here. This will change the variable, but it will, once I've created this, you can't change it. Okay, and they actually have a lot of very useful methods, especially it's pretty remarkable what you can do with these strings. You can, things like you can change the case, you can make them all uppercase, all lowercase. You can take them, you can split the string into its substrings based upon various criteria, including a very powerful way called regular expressions that we'll touch on. All of that is sort of much later. This is just an introduction. Okay, concatenation. So, and you've no doubt encountered this. So if I have two strings, I can jam them together using the plus operator. So if I have, here's one string that has the characters capital H, lowercase I. Here's a second string that has a space, capital M, lowercase o, lowercase m, and an exclamation point. And then if I add them together, or concatenate them using the plus operator. Now, okay, there are a lot of things going on here, so let me just kind of break them down a little bit. And it's important to understand this. Here, this piece declares the variable 1 to be of type string. This assigns the constant string high to the variable 1. So there are two things going on that line. So it's important to understand that. The consequence of immutability, see, if I just do this and leave that hanging, then nothing is going to happen. So what this does is this takes two immutable strings, creates a third immutable string, and assigns that to this string variable. Okay, so there's a lot of stuff going on. So I can print, and I didn't have to do this. So I could have simply printed out this piece right here without assigning it to a new variable. And if that's all I wanted to do, that would be fine. But then as soon as I move to the next line, all that would be lost. Okay, but because the concatenation and addition both use the plus operator, you say, well, what happens if we plus a string with a number? And it's, there are several things that could happen. One, the strict typing rule would say, okay, this makes no sense. You're adding apples and oranges, and so we're simply not going to allow it. Okay, that would be I guess the OCD version of that. Java decided they wanted to make things a little bit easier. Well, so strictly speaking, in a strongly typed language, you can only have an operation on two things of the same kind. So strictly speaking, I can only concatenate one string with another string. But under the hood, they do a lot of work for you. So, and it's not a law of nature or anything, but it's kind of natural. What it does is it takes the string, when it concatenates it with a number, it turns the number into a string and then concatenates the resulting string. Okay, so there's a lot of stuff going on under the hood here. Again, what it does is it takes the number, turns that number into a string in which the characters of the string are the digits of the number, and then it concatenates that with the string. So this will print this value. Okay, now what about characters? Well, it turns out that characters are treated as integers. Again, not at all, if you were to look at this, okay, they had some choices. they could have said, well, and in Python, this very operation would produce ACD. But in fact, in Java, it produces the value 296 because it takes the integer value, the Unicode value of these characters and adds them up and say, okay, you're a number. So it'll output the number. Okay, so here's a little here's a little teaser. You know, so therefore, can you reason what this will produce? That would make sense, but actually, what there are two things going on here. One is, remember, operations are go left to right. So when it goes left to right, it encounters this character. It says, oh, character is a number. So it'll produce a number. And then, so this piece will add two numbers together, take that number, and then now this is a string. That notice this is not the character D, this is the string D, and so I'm concatenate a number with a string. It'll produce whatever that number is with the letter D. And you know, I'll leave it to you to check all that out, but that's basically what it does. Okay, here's another gotcha, testing for string equality. So normally, if I have two strings, and I want to say, are these equal? Most of the time, they're going to be equal if they have exactly the same letters. And in a case-sensitive world, they're equal if the case also matches. So if I have exactly the same letters, but one of the letters has a different case, then they're not equal. They're not the same. So mentally, or intuitively, I have two strings and I want to treat them as being the same string. But the problem is, because they're objects, I can have two strings that have the same characters but are different objects. And so testing for equality, when I'm testing objects, asks, are these the same object? Are these the same object? And for strings, I can have two strings that have exactly the same characters. So it looks, if I look at them, they're going to look like they're the same, but they're not going to be the same object. And so they're not going to, so equals doesn't work. Now in JavaScript, what they added this sort of triple equal to kind of take that into account. Java didn't, you know, that wasn't around when Java chose a different path. And so in Java, if I want to test whether two strings are sort of equal as strings but not as objects, there's a method called .equals. So so here's an example. So I have two strings. So here's this, and then here's another string. Now I have not. I could have concatenated it. I mean, it would have had more or less the same result. But okay, here. So these. Concatenating these two concatenating these two should result in this in terms of the strings. But if I do that, and then notice the parentheses here. So the double equals is going to bind a little more tightly. So this is, if I leave the parentheses off, then the 2 is going to be, well, it's not clear, but again, programmer's intent. So here I'm clearly concatenating and then testing for equality. Okay, so this will produce false. Why? Because this results in a new object which is different from this object. So they are not the same objects, but they're the same characters. So if I want to test if they're the same characters, I use the .equals, and when it comes to strings, you basically just never use this. And in fact, NetBeans, like in the code, NetBeans will actually give a little warning. It says, hey, you're testing toString for equality. You shouldn't be doing that. Okay. Arrays. Now, you're familiar with arrays in both Python, JavaScript, they both have arrays, and they both do arrays completely differently. Or not completely differently, but very differently. Okay, so what an array can contain either primitive or object types. Okay, so an array is an object regardless of whether it holds primitives or objects. So as an object, an array variable, you have to declare it, because an array, for example, an array of ints is a different type than an int. Right? An int is a number. An array of ints is, well, an object that's going to have a number of ints in it. Okay, so again, like objects, with objects, with primitives, we have to declare a variable and then assign the variable a value to the variable. We have to do the same thing with objects. We have to declare a variable to be a particular type of thing, and then we have to assign a value to it. Now, what value? How do we create something to put in there? Well, with primitives, we just put the number in. With strings, we can kind of create them using the double quotes, but with objects, we have to use the new word. And you've hopefully seen, yes?
Arrays contain different types of data.
No. And this is one of the differences. Arrays can contain only one type of data, one type of thing. Now, having said that, though, once we start talking about classes and inheritance, an array can contain, well, at one level, my answer is correct. At another level, arrays can contain different types of objects, but only if they share a common superclass. In other words, and we'll get into that a little bit more. In other words, strictly speaking, I can only have one type of thing in an array, but once we look at kind of inheritance and polymorphism, we can have different types of things. So, but that's all a different topic. Unlike arrays in Python and JavaScript, once I instantiate an array of a given size, then that particular array object cannot be resized. I can't, if I say there are going to be 5 of them, and sometime later I decide there have to be 6, then I can't just shove a 6th one in. I'm going to get an error. Whereas like in Python, if I change my mind and shove another one, no problem. Same with JavaScript. And JavaScript, because they're untyped, there's no such thing as different types. So it's like the question has no meaning in an untyped language. In a typed language, it does. Okay, now, as the one thing and this is something that you'll hear me kind of complain. I'll try to not get on this soapbox too much. This is probably one of the stupidest things that's ever been foisted upon the programming community, and that is the zero-based indexing. It's so I have an array of length 4. So if you got 4 things, is it not reasonable to say what's the 4th thing? Doesn't that make sense? With arrays, and this is true across all modern languages, you can't ask that because it'll give you an error. So I got 4th. Why? Because of this indexing thing. Why is that there? That's there. This goes back to the C language, because all modern languages have C as their granddaddy. And in C, they were building C on these minuscule little machines. They were actually the size of a refrigerator, but they were minuscule in terms of their size, and they had to squeeze every last little thing out of them. And so what they decided was starting their arrays at 0 would save them an operation as it turns out. Why? Because the machine was so tiny that they had to squeeze that out. And ever since then, we have this index starting at 0. Like, you know, back in the day, Fortran arrays started at 1, as nature or God intended. I'll try to get off the soapbox on that. But why am I upset about this? Well, because it is guaranteed that you're going to get an off by 1 error. And what's an off by 1 error? It's like trying to access the 4th element of an array of length 4, which is a completely reasonable thing to do. So when the language makes you do something unreasonable, say, what's the 4th element of this array? Oh, the one at index 3. You know, what? You know, kind of. So it's, you know, it's like, you know, we've all been brainwashed that this is something that makes sense. And the fact is, it doesn't make any sense. It doesn't. It's stupid. And it produces errors. That's, you know, so it's not just stupid. It produces errors. It is guaranteed you will have at least one off by 1 error every month, at least, guaranteed. See, and now, and this is one thing that Java is actually very good about, though. They are bound checks. So if I try to access the 4th index of this, Java will say, nope, no, can't do. And that's good. That's a good thing. Okay, so how do we do this? Well, we declare variables using the square brackets. You're probably familiar with all this. There was something, and this goes back to the C days, do the brackets go here or do they go here? The only logical thing is that they go here. Why? Well, because what is the type of this variable? The type of this variable is array of ints. So the brackets go here. And in Java, that's the only way you can do it. In C, you can do it either way. So here's an array of ints. Here's an array of strings. These are both objects. So as objects, I need to instantiate them. And we'll get into objects and instantiate, but you know, this is still review because you've encountered this in your other languages. Okay, so here's how I do it, and this is very, very different than every other object except, well, with strings we have the double quotes. With arrays, we instantiate it like this, and when we instantiate it, we have to say how many there are going to be. So in the values array, after I've instantiated, I can only access indexes 0, 1, 2. That's it. And I can't resize it. Now, well, if I want to put a 4th element in, what I have to do, pretty much the only way to do it, is I have to instantiate a new array of length 4, put it into a temporary variable, then copy all of these elements into the new one, and then add that. You know, whereas what you've done so far is if I want to just add a 4th one, shove it in, no problem. Under the hood, what it did is it probably did some magic or work that, you know. Okay, so arrays can be of object. In this case, strings are objects. So here, this is going to declare an array of length 10 of containing strings. Now, so with variables, we declare the variables, we assign the variables, and then for arrays now, we have to assign the individual elements. And what happens if we don't assign the individual elements? Well, it's not clear. I mean, it's not a law of nature, but what happens is after instantiation, the contents of the array are the default values of the thing that we've defined. So the default value of an int is 0. The default value of a double is a double 0. If I have an array of booleans, the default boolean is false. The default value of an object, so now what is the default value of an object? So for numbers, there's sort of a list of them. They're all natural, you know. If I declare, you know, the default value of a number is 0 or its equivalent. But what about an object? For an object, there's a very special word called null, and that means it doesn't point to anything. And null is actually, it's actually kind of a mixed blessing, because the null value is the cause of something called a null pointer exception. And this is something that you're all going to encounter. It is something I encounter on a regular basis. In fact, just last week in one of my large simulations for NavSup, all of a sudden it produced a null pointer exception, which was a really stupid thing on my part, but it's like, you know, why, what happened? I fixed something and the fix broke something else, so that's, yeah.
Do you have arrays of mixed variable types?
Arrays of,
Mixed variable types?
no, no. I can't have an array of strings and ints. I can't have an array of ints and doubles. They all have to be exactly the same.
What about an array of two different arrays? Like an array that holds an array of and an array of strings?
Well, mean like this?
Kind of.
Yeah. So an array of an arrays. That's how you do multi-dimensional arrays, two-dimensional arrays. So, and logically, an array is an object. An array can contain objects, and so an array can contain an array. And that's, so for example, you know, jumping ahead a little bit, but okay, here's a two-dimensional array, and so it's an array of arrays. And in fact, that's the way to think of it. Normally we think of two-dimensional arrays as like a rectangular table, but in fact they can be a so-called ragged array, meaning that this array, well, so for example here, like, why might I do this? Well, I might have sort of a long and a short name for months. So I want 12 months, and for each month I want a short and a long name. So 00 would be Jan, 01 would be January. So here I've declared this array. This would be an array of length 2 containing an array of containing, sorry, well, you can look at it one of two ways. I can look at it as, this is an array of length 12, but this is sort of a two-dimensional, an array of length 2 of arrays of length 12. Okay, does that, yeah. And you can have 3, 4, you can have as many as you want because of the way it's outlined. And this is actually something that C did. Like back in the Fortran days, you couldn't do this, but that was one of the, okay? Yes?
I think what Tim might be asking is, when you do that multi-dimensional array, do they need both be strings, or can we have an array of one, like, for example, if you wanted the number of the month and the name of the month, could you make that multi-dimensional?
No. Yeah, yeah. And, well, to that, okay, so, well, okay, why not? Well, because doing that kind of thing using arrays is actually you know, kind of like trying to build a computer using Stone Age tools. Because if I want to represent data of different types, then the way to do it in an object-oriented world is to create an object containing a string, a number, you know, so the name of the month, the number of days in the month, et cetera, a Boolean as to whether it's leap year or not or whatever. Yes?
So instead of making an array of primitives, can you make an array of objects?
Absolutely, yes.
Okay, so the way we would accomplish something like that, like have an object that has Jan, have that object also have January and number 1, and then you make an array of those objects.
Exactly,
Okay.
yeah, yeah.
All right.
You know, and that's a more effective way to do that kind of thing, because when you try to do that using arrays, and if you're not in an object-oriented world, that's using arrays is pretty much the only way to do it. But then I need to know, okay, that index 0 is the name and index 1 is the number of days. And so I have to kind of remember that. But in the object, I would have name, number of days. And so if I wanted to find out those things, I could ask it by name, pretty much, rather than by having to remember, oh, it's index number 3 or index number 2, which is just asking for trouble. Okay, but yeah, great observation. Okay, so assigning individual elements, so we do that using, you know, by referring to the index, and then the off by 1 error. So here, an array of length 3. If I try to do values of 3, then we're going to get an error. So the individual elements now are, this is a primitive int. Now for some reason, people don't like typing. I don't know, you know. So it's like they come up with this idea of initializer block. Okay, oh, this is a really cool feature. Well, it is just you it's a feature. How cool it is, its main use for this. Okay, so here's what I can do. I can, instead of kind of going through all that, I can create the array. I can create the array and assign it I can just sort of pop the values in. And, you know, you can even leave this off if this you can even leave off. Why? Because I've saved, you know, 6 keystrokes and it hurts my fingers. The only utility for this is toy classroom demonstrations. So they added a feature just to kind of, when you are writing a serious program, you never do this. Because in a serious program, you do not want to have any hardwired data whatsoever. That is a state of sin. And, you know, and one of the reasons why there's all this other machinery is precisely for large, serious programs. You want all the data to be something that you read in from somewhere else. And that's the way all decent programs are kind of organized. I mean, I actually, I don't know if they use it anymore, but there was a simulation called the Navy Simulation System, NSS. And we managed to get a hold of the source code just for a particular project we were working on, and we were trying to manipulate. We were doing a study on sensors and stuff like that, and so we wanted to manipulate a particular value in this, and no matter how we changed the value, we wouldn't get the results were exactly the same. And so, having access to the source code, we discovered that there was a hardwired number inside the code that was preventing any changes to this particular happening. That is a mortal sin. No, you know, in your program, you should not have any hardwired numbers, ever. That's why this is kind of a it's sort of a convenient thing, but it's really pretty much useless, other than for someone like myself who's giving demonstrations. But doing demonstration, it makes it a little bit easier, but that's about it. Okay, arrays know how their length. So if I have an array, I'm going to say how long are you? It has actually And this is kind of a sinful thing, but it turns out it's sort of okay because arrays are immutable in terms of the size. If I say values dot length, notice no parentheses, it will give me how many there are. So I always know how long an array is, and that was a tremendously useful thing. Big advantage over C. Okay, we talked about multi-dimensional arrays. Okay, I want to talk about scanner, and for some reason the book, this is not in the book, so this is your only reference to it. This is a very useful class for at least certain things, at least for what we're doing. What it is it can be used to read user input. We're going to use it to read input from the command line, and you're going to be using it to read user input from the command line. But it turns out you can read it input from any data stream as long as it's text. And so, and I'll show you how we do that. And it has just a number of useful methods for input. So if I have a scanner and it's connected to a stream of data, where that stream comes from, it could be from a file, it could be from a user typing on a console, it could be from a network connection. Doesn't matter. I mean, it's sort of agnostic to that. All it knows is it's getting the stream of data, and that data is text. So next will return the next string. How does it know the next string? By spaces. Again, the normal thing. That actually can be changed. But I can say, okay, if I say next int, and the user is and the next token, as it were, is an int, then it will take that, and then I can assign that to a value. And then next double, likewise for a double. So here's an example of just some code. So here, I declare the scanner as scanner as a class. So scanner is now declared to be a variable of type scanner, and now once I instantiate it, then the scanner variable, well, let's see, here the value of scanner is null. Here, if the scanner is this new one, and what I've done is I've connected it to a thing called system in. We've seen system out, and we'll print. Guess what system in does? It reads in from the command line. So out to the command line, in from the out to in. Okay, so here we're going to give a prompt, and actually you've been seeing print line. I can also use print is also a statement there. What's the difference? Print will not go to the next line. So say enter some text, okay, one word, and then I'm going to read it in. Okay, this reads in the next word, and then assigns it to this string called, I'll call it user entry, and then I'll just sort of print it out. And then now I say, okay, now enter an integer. Okay, wait for the integer. The next int is going to get that integer and assign it to this variable here, and then I'm going to print it out. And then likewise for a double. And then finally, this is kind of optional, but just as a matter of course, when you're doing any kind of programming and you're using a system resource, you should always release that resource as soon as you're done with it. Now, yeah.
If you're using, say, scanner.next, it's going to read the next string input. So what if the input is number space string? Does it skip over the number and go straight to string?
Nope, just reads the next number as if it were a string. And we can sort of test, let's test that. Okay, so let's see how this is going to work with NetBeans. So the first thing to do is to clone the instructor's code. So how to do that? You all should have had access to this project. So if you go to GitLab online, you should be able to clone it. And so go to the clone button, you open it up, and then choose clone with HTTPS. Now copy that URL, then go to NetBeans, and then your project should be in there, but this will produce a different project. We do git clone, and then paste in using Command or Control V, paste in the URL, and then your username and access token should be the same. Choose your destination folder and say next master. In this case, I'm putting it here, and then open the project, and there you have it. So here's the scanner test that should be in there, in addition to my hello world. And so here's how we declare scanner. We instantiate it by giving it system in other words, the console. And then here's how we're going to ask it for the next one. Just echo that, and then just carry on with that. So to run that, we can just right click anywhere, say run the file, and then it's going to show up. Our console is in the tab called output, so we can enter some text. Now notice that I put underscores because what it's going to do is it's going to grab the whole the word up to a space. We'll see an example of that. And then now let's enter an integer, and then finally a floating point value, and it can handle some pretty big numbers. So and then notice that in this case it actually converted the number to scientific notation. Now you can get some errors. It's actually a little bit fussy about this. So if I wanted to do this, what it's going to do is, see, it gives me an error. So what happened? Now notice it said I entered hi, but then the next token, the next word was mom, and it tried to read that as an int. So it's very fragile in the sense that if it tries to get a next int, it'll fail if it's not an int. And similarly, if I try to give it an int that's not a number, not an integer, so here if I give it a floating point value, it's going to also give me an error as well. However, if I say enter a floating point value, but if I just give it an integer, it will promote the integer into a double. Now the other thing I want to point out is that notice that there is some in this opening part here delimited by a slash and 2 stars and closed off with a star and a slash. This is something called Java doc, and this is something which is going to be a requirement for all of the programs going forward, and we'll talk more about what that is. But the advantage of the Java doc is that I can actually generate it like that, and then when what I entered here notice it's HTML, so these are like HTML tag there, and so that notice it gave a slightly different font for that, and it just sort of printed that there. The other nice thing about Java doc is that so let's say I wanted to find out more about this scanner class. So if in NetBeans, if I just right click and say show Java doc, it will bring up the HTML which has been created for that. And then the the Java classes, for the most part, have very extensive documentation on this. So this is all stuff that's in the code. If I look at the code, in fact, I can actually can look at the code. If I go to the source code for this, I see that there's how that class is defined. But above this, see all this stuff here? This is all the Java doc that, see, starting here. And that is the code here, or the HTML, which has been printed here. And this is very extensive, so it gives like some examples. Yeah, we can do localization, so we can have a number of syntax, all kinds of information about it. It gives information about all the different constructors. So notice that I can actually read from a file. I can read from an arbitrary input stream. That's actually what we were doing. We can have readable byte channel, a path. So there are all kinds of ways that the data can be getting in, not just from the user console. What we did here, input stream, system.in is in fact a kind of input stream, and this was the constructor we used. And then there's also other, like this is all the methods, just in a list. And then it gives details on each of the, in this case, the constructors, and it gives details on each of the methods. So if you want to know how to use a method in this thing, we just have to kind of go and find it out.